Hey guys, this is just a quick video to sum up. You'll need this to do the last few problems on the Handon, and those problems were the ones that were dealing with some of the fractions. So you'll need that you'll need this concept for those problems. So first of all, what is a conjugate? A conjugate is quick definition of that. A conjugate, when it comes to our complex numbers, let's say we have something like a plus bi. That's our complex number. Let me put it down here. Our complex number is a plus bi. That's going to be it in standard form. A conjugate is basically going to be when you change the sign of the I term. So in this case, the conjugate of this would be a minus bi. So basically, the conjugate is when you change the sign of the I term. Now, the reason this conjugate piece is helpful is because by changing the sign of the I term, it will get rid of the square, and I'll explain to you why that'll happen. So if we had a complex term, let's say it was 2 plus 3i, then the conjugate of that would be 2 minus 3i. If we multiply a complex number times its conjugate, we'll get rid of the square root term or the imaginary term. So this is how we would do that. We're going to do that the same way we were in class today, where we would distribute. So we'll start off with distributing. 2 times 2 will be the 4. 2 times a negative 3i will be negative 6i. Then we'll move to the other one. 3i times 2 is plus 6i. And then 3i times a negative 3i is going to be negative 9i squared. Now, the reason, again, we do this conjugate is when we're trying to get rid of the I squared term, or the I term, I should say, not the I squared term. Whenever we want to get rid of that I term, because these middle terms will cancel, plus 6 minus 6 are gone, and we'll be left with 4 minus 9i squared. Again, we can replace the I squared with negative 1, so it'll be 4 minus 9 times negative 1, so it ended up being 4 plus 9, which is 13. So the reason we do this is because we don't want the I term. The I term is going to always be a problem when we're dealing with the fractions. This is how you deal with the conjugate period. But the reason we need the conjugate and we need to do this is because I alluded to it, but we didn't really do any problems with it. When I mentioned the rules of radicals the other day, one of those rules of radicals said, I think I put it in the third spot, it said that there can be no radicals in the denominator. So with that in mind, if I have something like 7 over I, even though it might not look like a radical, what I stands for is the square root of negative 1. So we do have a radical in the denominator at that point. So what you're going to need to do is get rid of the radical in the denominator. The way we get rid of radicals in the denominator is we can do a few different things. We can square it, etc. If we had an I squared is negative 1, so we can get rid of the I in the denominator. If we had an I to the 4th, that's positive 1, so we can get rid of the I in the denominator. And if we end up with a complex number in the denominator, like let's say we had something like 2 plus, let me rewrite this. Let's say we had an example. Let's say we had something like 2 over 3 plus I in the denominator. In this situation, we can't just multiply by I because we would still have 3i plus I squared. We wouldn't get rid of it. So what we're going to do is to get rid of these radicals in the denominator when it's a complex number, we multiply by the conjugate. So let me start with this as our first example. So let's do that example I just wrote. So example 1. So it was, I think I said 2 over, I don't remember what I said, I'm just making up something else. 3 plus I. So if we take this as our first example, again, we can have no radicals in the denominator. That's the issue. So in this case, the way we're going to get rid of the radical in the denominator is to multiply by the conjugate. So the conjugate of 3 plus I is going to be 3 minus I. Again, all you're going to do is change the sign of the I term. If it's a positive, it becomes negative. If it's a negative, it becomes a positive. So we're going to multiply by the conjugate. Now, when we multiply by the conjugate, we're going to do that top and bottom. The reason we do a top and bottom is because if we multiply by the same thing top and bottom, it's the same as multiplying by just 1. And if we multiply by 1, it doesn't change the outcome of our problem. So that's the reason we can always multiply by the same thing, top and bottom, and it not change the final answer. So if we multiply the top, again, we've essentially, I'm just going to write it this way. We'll have 2 times 3 minus I. So when you multiply that out, you're going to get 6 minus 2I. On the bottom, we'll have, just because of space, I don't want to write the whole thing, 3 plus I times 3 minus I. So on the bottom, what we'll end up with when we distribute, 3 times 3, we'll get 9. 3 times I, we'll get negative 3I. Then we distribute the second term. I times 3 is 3I again. And then I times I is minus I squared. We simplify that, we're going to end up with 9. The I terms will cancel. And then this will be minus a negative 1. Minus a negative 1 will end up being plus 1. So it'll end up being 6 minus 2I over 10. Now, that is your final answer, but this can be reduced. The reason this can be reduced is because all of these numbers have a factor of 2 that can be pulled out. You can only reduce if all of the numbers have like that same like GCF or something that you can pull out. So all of these are even, so we can pull a 2 out of all of them. So our final answer would be 3 minus I over 5. And again, that's because we're factoring out a 2 from everything there. Final answer is that. All right, let's try another example. Let's try example 2. For example 2, let's take something like 8 over I. If we have 8 over I, this would again be considered an improper final answer. The reason this would be an improper final answer is because we have a radical in the denominator. Again, because I is a square root of a negative, so it's a radical. So we're going to fix that by multiplying by I. I know that if I multiply by I top and bottom, it's the same as multiplying by 1, so it's not changing my final answer, so it's legal. And if I multiply this, I'll end up with 8I on the top, and in the denominator, I'll have I squared. I'll end up with 8I up top over I squared is negative 1. So my final answer here will be negative 8I, because 8 divided by negative 1 is going to be negative 8. And that would be it. So again, sometimes our goal is to multiply by the conjugate. Sometimes we just need to get that even I. So if we just need to go for like an I to the second or an I to the fourth, we can just multiply accordingly to get that to happen. So we'll do 2 more, and these 2 we'll do with the conjugate, because those are the ones that are a little harder. So let's take example 3. For example 3, let's take 3 minus 6I over 5 plus 2I. So this one's a little bit harder than the first example we did. The reason this one's a little harder is because we have 2 terms for both. We have, well, I should say complex numbers for both the numerator and the denominator. So when we have these complex numbers for both, we still only care about the denominator. So we don't care if the top is complex or has a radical, that's fine. The issue is if the denominator is complex or has a radical. That's where it's improper in our math world. So what we're going to do here is we're going to multiply again by the conjugate. The conjugate is, again, we multiply the conjugate of the denominator by the conjugate of the denominator. And our conjugate of the denominator here is, again, going to involve us just changing the sign of the I term. So in this case, it's going to be, we're going to multiply by 5 minus 2i. And again, we cannot change our top and bottom when we multiply. It has to be the same thing. By it being the same thing, again, that's 1, so it keeps it equal. It makes it legal to do. We can't multiply by 2 on the top and 7 on the bottom and then say that these things are still equal. So then we're going to do our equal sign. Again, the multiplication, it's going to be 3 minus 6i, that's what we're multiplying on the top, times 5 minus 2i. On the bottom, we'll be multiplying 5 plus 2i times 5 minus 2i. Up top, when we distribute this out, I'm going to just do it and then the combining. We'll have 15 minus 6i minus 30i plus 12i squared. Denominator, 25 minus 10i plus 10i minus 4i squared. Combine like terms at the top, I will end up with, just change colors here, I'll end up with 15 minus 36i minus 12. Because again, I'm just going to try to skip some steps. I want to write it so many times. It'll be 12 times negative 1 there. That's where I'll get that from. In the denominator, I'll end up with 25. These 10 i's cancel out, plus 10 minus 10. And then I'll end up with a plus 4. Because again, this would be negative 4 times negative 1, which is a plus 4. So my final answer will be 3, because 15 minus 12, minus 36i over 29. So again, by multiplying by the conjugate, we've gotten rid of any i's in the denominator, any radicals in the denominator, and that's our goal when we're multiplying by the conjugate. All right, and our last problem for today, I'll let you guys go. Let's take example 4. And for example 4, let's take 6 plus 2i over 3 minus 5i. Just want to switch the sign up because all the other ones had a plus, so I just want to make sure it's clear. All right, so for example 4 here, again, what I want to do is get rid of this I in the denominator, or the complex number in the denominator. So to get rid of that complex number in the denominator, again, I'm going to multiply by the conjugate of the denominator. So the conjugate of the denominator is going to be, again, me changing the sign of the I term only. So not both, just the I term. So when I change the sign of the I term, what I'm going to end up multiplying by is going to be 3 plus 5i. And again, that thing I'm multiplying by needs to be the same top and bottom. So then what I have is 6 plus 2i times 3 plus 5i. And in the denominator, I have 3 minus 5i times 3 plus 5i. I go ahead and multiply this all out. At the top, I'll end up with 18 plus 30i plus 6i plus 10i squared. Denominator, I'll have 9 plus 15i minus 15i minus 25i squared. All right, so here comes the math. Equals 18 These two give me 36i. And then again, this 10i squared will be 10 times negative 1, so it's minus 10. Denominator is going to be 9. The 15i's will cancel. I'll end up with negative 25 times negative 1, which is plus 25. So my answer is going to be 8 plus 36i over 34. Again, for this one, hopefully you notice they're all even, so I can take out a GCF from 8, from 36, and from 14. So my final answer would be 4 plus, 18i over 17. Final answer. All right, guys, that should be enough for you to finish up the exit card for the homework. Have a great day. Remember, this is due by midnight.